Okay, Assalamualaikum. So today our group consists of me, Alif Maimin, Aiman Hafi, Faris Anaki, and also Muhammad Adli would like to present our case study in research of sustainable material. So our case study divided by two, which is first, laterite-based stabilized products for sustainable building application in tropical countries. Also second, coconut shell as a substitute for coarse aggregate in concrete. Okay, for introduction of laterite, compressed earth blocks are one of the most common applications for laterites in construction. CEB's manufacturing process allows for the current usage of lateritic soils in wall construction while still meeting structural performance criteria. Furthermore, a great aesthetic quality of the structures are possible to be constructed. The goal of this study is to evaluate the research that has been done on improving lateritic soils for construction purposes in order to promote this technology. In order to support the development of the industry, emphasis has been placed on product quality and environmentally responsible techniques, building policies that are both ecologically friendly and sustainable. So for methodology for laterite base, first we have mechanical stabilization. The method compacting the soil to change its resistance, compressibility, permeability, and porosity is known as mechanical stabilization. The soil is mechanically processed to remove as much as possible, resulting in an increase in density. Next, number two, we have physical stabilization. The method is physical stabilization entails altering the qualities of soil by adjusting its texture, granulometry treatment, dehydration or freezing, or electrosmosis treatment that cause the soil to drain and confer new structural properties. Third, we have chemical stabilization. Chemical stabilization is adding other materials or chemicals to the soil to change its properties, either through a psychochemical reaction between the particles and the added components or by forming a matrix that binds or covers the particles. Okay, for lime stabilization, carbon 2 plus is partly absorbed on the surfaces of clay particles when lime is introduced into soil for stability, replacing monovalent cations such as Na and K. The amount of Ca2 plus that has been absorbed depending on the treated soil's cation exchange capacity. The lime fixation point is the amount of lime required to satisfy the soil extraction for lime. For cement stabilization, the hydration of the two anhydrous calcium silicates, the principal ingredient of cements, result in the formation of two new compounds, which are calcium hydroxide and calcium silicate hydrate. Okay, for fourth method, we have low temperature geopolymeric settings process. Alkaline reagent produce positive ions such as Na, K, and Ca, which must be present in framework cavities to balance the negative charge of aluminum in 4-port coordination. This ion serves as catalyst, allowing mineralogical components to react, reticulate, and set in place. The binder for agglomeration in situ is produced by the argillaceous material itself. So that's all from me. I would like to pass to Adli for the next presentation.
Thank you, Alif. Okay. So next, for the result, there's 4 diagrams that shows the result of this case study. So the first is compressive strength versus factors and modalities. The second one is factors and modalities versus water absorption in percentage. Third is factors and modalities apparent density. And the last one is compressive strength, the difference between cured water and dry out. So next, the geopolymeric cross-linking is more or less complete, depending on how much alkaline reagent is given to the argillaceous material. One can remark about a lateritic soil. When alkaline reagent is added at 0.5 to 2% by weight, the soil is stabilized with a good behavior against water. With 2 to 5% alkaline reagent, blocks are water stable with a compressive strength ranging from 4 MPa to 6 MPa. With 5 to 10% alkaline reagent, blocks are comparable to fight brick with a resistance ranging from 8 to 60 MPa. These mechanical characteristics depend on the setting temperature. Each setting temperature uses a particular finished product. All materials manufactured with LTGS, geopolymeric cross-linking, preserve the quality of comfort specific to earth materials. This quality is neither disturbed by the medium temperature treatments, 85 to 450 degrees Celsius, nor by the quantities of alkaline reagent added. The production of geopolymeric stabilized-based lateritic salts for construction purposes in Cameroon is still at the level of laboratory experimentation. Due to its environmentally friendly manufacturing process, studies are ongoing to start additional industrial production. Several other studies have shown that there is potential to produce building materials presenting good civil engineering properties with earth or lateritic salts. Next. In conclusion, lateritic salts are abundant in Africa and can be utilized in variety of ways to create building materials with good civil engineering qualities. Government in Cameroon and other countries in Africa continental could implement strategic policies in stimulating research on local materials and conducting effective training programs on the use of earth-based construction materials. These low-cost materials can help to solve the problem of inexpensive housing that reduce the construction cost. By utilizing local technology, local labor, and local resource, considerably higher productivity levels can be achieved on a minimum budget. Furthermore, the outcomes will allow these dwellings to be maintained and prepared utilizing local expertise and resources. It will be easier to solve Africa's affordable housing problem now that technology and resources are available. This amazing discovery could encourage other countries around the world to conduct more research on renewable local natural materials that possibly could be used in construction materials in order to reduce the reliance to unrenewable construction materials and look for cheaper options. So thank you very much. For the next slide, I will pass to Muhammad Hafiman. Thank you.
All right, thank you, Muhammad Noadili. So, all right, next for the next article about coconut shell as substitute for cost aggregate in construction, in concrete. So, the introduction is, in recent years, researchers have also paid more attention to some agricultural waste for use as building material in construction. Periwinkle shell was used as substitute for coarse aggregate in concrete, and palm kernel shell was used as replacement for fine aggregate in concrete by some researchers. Certain investigations used crushed granular coconut and palm kernel shell as substitute for conventional coarse aggregate, and the result for the test showed that the compressive strength of the concrete decreased as a percentage of the shell increased. The properties of concrete using coconut shell as coarse aggregate were investigated in an experimental study, and the study concluded coconut shell concrete can be classified under structural lightweight concrete. It is clear from the research listed above that coconut shell can be successfully employed as a coarse aggregate alternative in concrete. The goal of this research is to determine the best range for replacing coarse aggregate with coconut shell based on their strength qualities. The study also intends to determine self-weight reduction, the benefit of commercially produced coconut shell concrete work. The methodology that used was workability test. There is with each concrete can be moved, poured into mold, and compact with appropriate surface finishing without separation is defined as workability. The slam cone test was used to determine the workability of the various mix, and the consistency of each mix was determined. Next is compressive strength test for each type. 3 cube were cast, and the average compressive strength of this was used to determine the compressive strength value for each mix. Next is fractional strength test. Fractional testing was performed according to IS 516-1959 using a 2-point loading method. The load of the beam was introduced with a shock and gradually raised until it failed, with the maximum load applied during the test being recorded. Last but not least is splitting tensile strength test. The test specimen was carefully positioned along the vertical plane at the top and bottom of the specimen in the centering jig with packing strip or loading pieces. The applied maximum diametrical load was recorded. The result and discussion. So this is the result for the splitting tensile strength test. The next one, this is the strength test result lectures. Alright, so this one is the result for the reduction in self-weight calculation. The table 2 here is workability test result, as you can see. So the table 1 is type of strength test and specimen, refer to the table 2. Table 3 is compressive strength test result, according to the percentage of replacement of aggregate. Workability was observed to improve as the fraction aggregate replaced with coconut shell increased. The smooth surface of the one side of the cell, as well as smaller size coconut shell compared to traditional aggregate, provide coconut shell superior workability. The average compressive strength was 25%, replacement mix was 22.62 megapascal, which nearly 94.25% of the strength of normal concrete. For 30% and 100% replacement, we achieved compression strength of 14.93 megapascal and 5.48 megapascal respectively. The finding indicated that coconut shell concrete can be used in hard strength application with replacement of less than equal to 25%. In addition, for non-loading bearing building, we can apply higher percentage and replacement. Breakage of the coconut shell aggregate was observed on the failure surface, demonstrating the individual strength press had significant impact on the final concrete strength. All right. Next, I pass to Anaki.
In conclusion, coconut shell is experimentally proven to be the right alternative choice to substitute coarse aggregate in concrete mixture materials. There are very low description for workability with lump con value between 5 to 15 mm, which make the compacting factor of 0.778. This better condition of workability is believed due to a smooth surface on exterior side of the shell and the size of coconut shell used during the experimental test. Besides that, the mixture with 25% replacement coarse aggregate to coconut shell resulted in average compressive strength of 22.62 MPa from the compressive strength test. It is about 94.25%, similar to the strength of normal concrete of 24 MPa. Last but not least, there is a large reduction in self weight due to coarse aggregate have been replaced with coconut shells, in which can be used to benefit construction concretes. In a nutshell, this research should be continued over time in the future with innovative ideas to benefit the coconut shells as replacement of to coarse aggregate in construction cement mixture. Rapid urbanization has resulted in an increase in the amount of construction waste. There are still certain gaps in this research, such as discovering how to improve the quantities of building waste around the world, which necessitates the formulation and implementation of sustainable management plans. As a result, it might be improved further by mentioning the remedy or, at the very least, how to reduce the damage in each category. Recycling and reusing construction waste as part of a sustainable waste management strategy will help to minimize cost, pollution, energy demand, and natural resource conservation. Engineers and material scientists will use this as a guide to produce standards and specifications that are both cost effective and energy efficient. Next. As you can see, this is our reference for our slide and for our research. And thank you. That's all.